For some years now, the chemical industry has been working on materials that are both efficient and environmentally friendly. These could revolutionize not only the battery industry, but also our everyday lives. But do you know what we're really talking about? Lately, boron nitride has been at the center of attention. As you've probably gathered by now, batteries are undergoing a veritable revolution. For a very long time, lithium-ion technology dominated many industries. But today, this is no longer the case. As a result, sodium has decided to try its luck. But it's boron nitride that's set to revolutionize battery technology. Indeed, boron nitride cooling charge materials are often used for thermal management in certain appliances, notably cars. But what is boron nitride really? How does battery thermal management work? Can boron nitride cooling charges really change the future of batteries? In this video, we'll attempt to answer all of these questions. In reality, boron nitride is an integral part of our everyday lives. What's more, safety and the environment are particularly important issues when it comes to new materials. Is boron nitride really the new carbon? Can it really revolutionize the automotive industry? Batteries are currently undergoing a revolution, with a host of new materials making their appearance. In recent years, lithium-ion technology has completely dominated the automotive industry. In electric cars, the battery accounts for around 40% of the vehicle's cost. It is therefore a central element in this constantly evolving market. It is lithium-ion technology that has established itself at the heart of this industry. It has long been the most advanced technology. Simply put, the cell is the electrochemical center of the battery. The battery is made up of four essential elements. These are the two electrodes, the cathode, the anode, the electrolyte, and a central porous membrane. The latter's role is simple: to protect the electrodes and prevent short circuits. As a reminder, electrolyte is a fluid mixing solvents and salts. Lithium ions have long been favored in salts, not only to circulate between electrodes, but also to generate energy. According to many chemists, this lithium base still had a chance of surviving. But this was without considering the emergence of particularly interesting new materials. Researchers hope to reduce costs while improving performance. They're therefore ready to invest in certain new materials, which in their view are worth the effort. Sodium has tried its luck in this field. Whether for telephones or electric vehicles, lithium-ion batteries remain the most popular on the market. Their relatively low production costs are very appreciated by car makers. However, this low-cost production is not without consequences for the environment. It's true that each battery contains several kilos of lithium, which is mainly produced in Australia and Chile. However, these countries are a long way from where lithium-ion batteries are produced. Transporting the material therefore represents a real ecological disaster. What's more, lithium mines require huge quantities of water. We're talking about 2 million liters of water for 1 ton of lithium. Of course, like all fossil fuels, resources are already being depleted. As a result, engineers have chosen to focus on sodium. For a start, sodium is much more abundant on Earth than lithium, and has less environmental impact. This makes it a perfect ecological alternative. Economically speaking, sodium-ion batteries are also a winner. It's for all these reasons that sodium-ion batteries will be making their appearance on factory-built electric vehicles as early as 2024. Thanks to their low-temperature performances, they have won unanimous approval. However, in terms of energy density and weight, sodium-ion batteries still have a long way to go. What about boron nitride? Is it really set to revolutionize the battery industry? Boron nitride enables better cooling of electronic components. The aim of these new materials is to promote sustainable mobility, and therefore to analyze the environmental impact of the products used. Boron nitride is one of a range of materials enabling the development of nanometric electronic components. These inventions are making headlines in the automotive industry, and researchers are keeping a close eye on the issue. Are we truly at the dawn of an incredible technological change? Boron nitride cooling change materials are now widely used in battery thermal management. But what is boron nitride really? Boron nitride is a compound with the chemical formula Bn, referred to as the isoelectron of carbon. Boron nitride is made up of an equal number of boron atoms and nitrogen atoms. Nitrogen atoms flank carbon in the periodic table of elements. Boron nitride exists in two different varieties. The first is graphite-type boron nitride, known as HBN. It's an excellent insulator. It even has superior lubricating properties to graphite at high temperatures. HBN microparticles can provide instant cold lubrication. This creates mechanical reliability for engine piston cylinder pairs. HBN also provides excellent thermal conductivity. On the other hand, we're talking about diamond-type boron nitride. This form, known as CBN, has a cubic structure. Its hardness is exceptional, and its value is close to that of a diamond. Boron nitride of this type is also highly abrasive. It's even more resistant to heat and impact than diamond. Now that we know a little more about boron nitride, it's important to understand how battery thermal management works. So what do you think? As you know, the automotive sector is undergoing a number of changes. The principle of carbon neutrality is driving a shift towards electric vehicles. As a result, battery thermal management systems are becoming increasingly important. The liquid cooling solution must be well designed and feature quick connectors. This not only dissipates excess heat, but also prevents heat loss. Charging times are reduced, as are temperatures. The battery thermal management system monitors and controls rising battery pack temperatures. Quick connect fittings contribute to incomparable thermal management. The materials used must be adapted to the type of coolant used in the system. At present, boron nitride seems to be the ideal solution. Indeed, boron nitride coolant charges meet the challenge of thermal management, not least because it's known for its thermal stability and conductivity. These properties have led to the development of a family of lightweight ceramic fillers. Added to polymers, these improve thermal conductivity, while maintaining electrical improvement. Cooling fillers based on boron nitride achieve high heat dissipation and meet electrical insulation requirements. Boron nitride also has multifunctional properties. This material therefore helps to reduce the size and weight of components, which also has an impact on system cost. Boron nitride enables all components to dissipate heat efficiently and achieve long-term reliability. So, boron nitride seems to meet all the requirements for a battery that performs in every respect. The future of batteries looks bright. Numerous inventions are proof of this. Researchers at Shanghai Jiao Tong University have invented a cover that protects batteries from temperature variations. 10 times more powerful batteries are also invading our phones. Is this the result of the discovery of the advantages of boron nitride? Boron nitride is now an integral part of our daily lives. All modern devices must maintain reliability and efficiency over the long term. This is what enables the buyer to take the plunge and invest. These devices require the use of advanced materials to transfer excess heat into the ambient air. The most convincing examples are laptops and smartphones, as well as electric and hybrid vehicles. As technologies advance, more and more products incorporate 5G components, which require more electronic components. They also generate more heat. As a result, the challenge of thermal management has never been greater. Similarly, safety and the environment are paramount. That's why researchers spend their time researching new types of cells and batteries. These new inventions have to be much safer in their chemical composition. They must contain as few rare materials as possible. Batteries are playing an increasingly important role. Their effect on people and the environment must therefore be positive. These new batteries must also meet market needs. Recharging times must be faster. Electric vehicles need to be more autonomous. Of course, green energy remains the priority and must be affordable for all. For all these reasons, cells and batteries are at the heart of research into technological innovation. Is boron nitride really the new carbon? Its exceptional properties of strength, rigidity, and tolerance to the highest temperatures would seem to make it the ideal replacement for carbon. However, achieving such quality can be very difficult. What can we expect from boron nitride in the future? The battery industry has been undergoing a revolution for some time now. For a long time, lithium-ion technology dominated the automotive industry. Sodium tried its luck, but it's boron nitride that's set to revolutionize battery technology. Boron nitride cooling charge materials are used for thermal management. Boron nitride is made up of boron and nitrogen atoms. It provides long-term stabilization of battery thermal management. So we're talking about boron nitride cooling charges. The future of batteries is therefore in a state of upheaval. Do boron nitride batteries have a real future?